so we should get started. Okay, welcome to the February 1st, 2022 session of TangerineSDR and Hamside technical session. My name is Dave, KV0S, and this week I've been recompiling some software. I've been back to working on the KA9Q radio stuff on a upgraded Raspberry Pi. So we'll see if it helps at all. There are still things to fix. So that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. It has been a busy week. First of all, happy early Groundhog's Day to everyone on the call. Next, I think a number of things that have been in progress are starting to come together. So I finally got the University of Scranton to agree to the hotel contract with the Marriott for the Hamside workshop. It was a long struggle, but I got the provost to sign it today. And so it's off to them. So hopefully I'll actually be able to open up the Hamside workshop registration this week. The registration page is, they are making it at the University of Scranton. I saw a draft of it. Hopefully by tomorrow I'll have the actual thing and I'll be able to put it up online. So I'll be good. Technically tomorrow the abstract deadline is tomorrow. I think we have about 17 abstracts in so far. I'll double check really quickly. So I'm going to review those, and in the past I have sometimes extended the abstract deadline another week or two if we needed to. And the other thing I'll probably do is I'm going to look through what abstracts have been submitted, and I may end up asking certain people to contribute abstracts even if they haven't already. So both from this community and possibly from the professional science community as well. The reviews from my GRL, Geophysical Research Letters article on the large-scale traveling atmospheric disturbances came back, and they were very positive. So I got minor revisions on it. I have, so they want the revision back within 2 weeks. But everything is due all at the same time.
Yes.
But that was a really, really positive result because so that, and GRL is it's a fairly high impact journal and very, very, very well respected. So that's a big deal. The other really good news is that we are now officially a NASA citizen science project. So if you go to science.nasa.gov/citizen science, and I can put that in the chat right here, you can scroll down, and there we are among all of the other official NASA citizen science projects. So we are on the webpage, and that's a photo of me on my roof at my mom's house with my friend Joe from college, and we're installing a G5 RV Junior. My mom took that photo years ago.
Very nice.
So that's where that came from. So I think, and then also this weekend, I wrote the final report for last year's Hamside workshop grant and the outcomes report. So that's almost ready to close out the previous grant. So there's all sorts of other things going on, but I think those are some of the major highlights. So we're moving along.
Sounds like you're a busy person.
Back to net. Oh, and I got my faculty annual report in as well. So
oh, very good. So next on the list is Dave, KD0EAG. Go ahead, Dave.
Okay. Yes, I finally got my two monitors aligned so that I can move the mouse sanely from one to the other, and that helps. I've not been doing anything very profound. I'm playing with an MPPT controller and a solar panel and a battery, trying to set up remote sensor stuff. But other than that, nothing very earth-shattering. So over to you all.
Okay. Next on the list is Bill Engelke, AB4 EJ, JE. No,
Thanks, Dave. I just now got some comments back on the NASA paper from our computer science prof, and I haven't had a chance to look at them yet, but we'll work on that. Have been working on the NASA project a little bit, and also figuring out ways how to plot data that comes off of. I'm running the grape in such a way as to collect full spectrum data in digital RF mode and figure out ways to plot that. So I want to have a nice way of plotting a couple of days, a day or two worth of ionospheric observing Doppler shift, and so that we can include that with what we give people on the, for looking at data that comes up the central host after we've uploaded it and all that. So anyway, so that's about all from here. Back to Nick.
fine business. And next on the list is Bill in 8ET. Go ahead, Bill.
Okay, yeah, I've got something to report this week finally.
Well, good.
I spent the week working with the 3D printer that we got. And there are all the parts that have come off the printer. And here's the one that I just did today. I've got to get the, finally figured out how to do supports that, here, let me get another one. Part will look about like that. When you print it, it prints support in there, and that I think is supposed to break out, but I haven't quite figured out how to break it out of there yet. When it comes out, why it'll probably be a nice even curve. This one, the original one, you probably can't see that, but there's all kinds of little hairs on the bottom that didn't, it prints across there, but there's nothing under it to support it. Why the threads that it spits out kind of dangle, and I've already cut a lot of them out of there, so I think that's usable, but not sure. So I printed a good one, and I'll see how that comes out once I get the supports broken out of there. Today finally got I printed off a PowerPoint that he has so that can figure out what parts I've really got to get, because some of the parts you have to print them mirror image of or print to, and so I've got to do that. There's a few I'm missing still, and the pictures in the PowerPoint don't look like the parts that I printed, so I've got to have to reconcile what's in the PowerPoint with what I've got. I think there's it's kind of a work in progress, and so that's an earlier version, so I think I'm all right. So I still got some question marks, but I spent all week on that. It took a little time. About halfway through, I had to take the plate off and chip one of the parts off because it adhered to the plate so well, and that messed up the leveling, and so I had to get the leveling back, and that killed an afternoon just getting it all straightened out again. But I've learned a lot about the printer, and now I'm ready to go. So we can get the rest of them straightened out. Jonathan, if I'll catch you after the meeting, we can go and I can look at the individual parts with you. So we'll see how that works. So that's it for me, Dave. Go ahead.
Okay, very good. And next on the list is Dan in for XWE.
Thank you, Dave, and good evening, everyone. Well, spent a little bit of time trying to organize a demo for the Orlando Hamcation. I think we're going to do one that either has FT8 or has listening to whisper beacons on it, something that's kind of WSJT X oriented. And Orlando's coming up in about a week and a half plus a day or so. So that's about it from here.
Very good. And next on the list is David in one HAC. Go ahead, David.
Hello, everyone. It's down to 10 degrees here. It was 11 minus 11 last night. So we're having a fine winter here. Let's kill off some pests. Anyway, continuing to work on polar projects, both ends, and wondering where I'm going to SCUA a server class computer so that I can put 128 gigabytes of memory in. We don't have any that I can just take over.
I think they have some old Mac Pluses at our rival heights you can probably borrow.
Yeah, there you go. But yeah, I'd like to play with the chirp sounders, and hopefully we can get it down so that software doesn't need quite so much memory. But anyway, I've been looking into that. And I guess, yes, Nathaniel?
Yeah, I'd really love to see someone look at that code and try to optimize it so it doesn't take up that much memory. I agree.
Yeah. We need to have something tracking them automatically rather than taking in all the data.
Yeah.
But I guess that's what FPGAs are for, if we can figure out how to make them do it. Okay.
Okay.
Well, back to net.
Well, fine business. And next on the list is David Wa, KE8 QEP. Go ahead, David.
Okay, well, good to see everyone tonight. I have been busy other than my day job, which is, somewhat inconvenient, although I like it very much. But I've been studying for the general exam. I'm taking that this Saturday, online. And I did see on my Whisper monitor on 10 meters, saw KVOS come across from Missouri.
Oh,
and I
very
saw
good.
that the call sign, and I'm like, oh, I know who that guy is.
Yes.
So that was fun. And other than that, I'm hoping this weekend I can pick up the remote, or actually it's a local magnetometer board I can convert to a remote magnetometer board from Bob Benedict, who is just 10 minutes away. Although I may get distracted if I'm sure I'll pass my exam, but I may get distracted. But hopefully we'll get that done. That's it. Back to net.
Very good. Yeah, I've been doing Whisper for many years now. So Scotty once had a story about seeing a magazine page that had a Whisper map, and my call sign was in the middle of it. So anyway, next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Not much to report, so I'll turn it right back to that. Thanks, Dave.
Very good. And next on the list is James, KG4 DSG. Go ahead, James.
Evening, Dave and the group. Not much to report here. I'll just turn it back.
Okay. Next on the list is Jay, WB8 SBI. Go ahead, Jay.
Good evening, everybody. Not a whole heck of a lot to report. Very glad to hear that the accommodations for the conference are being settled so that we can make the appropriate reservations. Detroit is a 10-hour, 600-mile drive from the event, and I'm planning on doing it on a 2-day thing, and myself and hopefully somebody else are looking very much forward to doing that. Haven't had a lot of time to do ham radio stuff. Been active in cybersecurity matters for the Society of Automotive Engineers. And I just got drafted, shall we say, to be a chairman of one of the other subcommittees. So that's been taking up a lot of my time here, and will continue to take up a lot of my time here in the foreseeable future. Otherwise, big snowstorm coming in tomorrow to the Detroit area, 8 to 14 inches. starting tomorrow night. So we're all set for that. And otherwise, not a whole heck of a lot going on here. Take care, everybody, and hope to see you all later on down the log. And maybe if I get a chance, maybe I'll catch you on FTA. Back to net 7-3 all.
Very good. And we're, I think, in that same storm. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. I have continued to play around with the data from the propagation issues on the 15th, the day of the big excitement in the South Pacific, and trying to establish or debunk a correlation between the strange things that we saw in the ionosphere and the events down there. Not having a whole lot of luck at this time. I've looked at it several ways and having some trouble. I've looked at the time between the event in the South Pacific and the time that things started going crazy is measured in the ionosphere in the US. And I have reports from 8 stations now spread out, one of them in the Netherlands, the others all in the US. And for some strange reason, too many of them in Ohio. Not that I object, but it doesn't help me too much with trying to look at things spread out. Got one, of course, in Georgia, that's me, one in Pennsylvania, and one in out west, but he was so close to WWV that we don't see as much in his data. So I'm still trying to make some sense of that. And one of these days I'll talk to Nathaniel and talk to see what the next step should be. Back to net.
Fine business.
But Jim, all our stations in Ohio provide a control. I mean,
There you go.
seriously, with what, there's like 5 stations there in a close proximity. It's sort of a perfect control.
Yeah, I think I have 4 of them. If there's time tonight, I might like to put up what I've got so far, but it's not necessary. There you go. Maybe that's control. It is comforting that all of those Ohio stations did get something similar. If they'd all gotten something entirely different, I would have been very concerned about the data we're taking. But
Yeah.
they did get something similar. And there are differences between the other stations, but tying those back to something in the volcano has been difficult.
Yeah, I can imagine that would be tricky. And I also think that this is where when we do start having everyone take full spectrum data, I think it will make it easier to disambiguate some of these signals. It's very tricky when you just have that single trace.
Quite possibly, yes. That might help. I was supposed to be converted over to that, but I got on this other thing and just haven't done it yet. Although I've got the parts, I just don't have the elbow grease. But yeah, that may help.
Yeah, maybe
Very-
when we get to the open session, we can talk about it some more.
Okay,
So if you're done,
I'm
Jim?
done.
Okay.
Yes.
Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everybody. Nothing to report from here. Thanks, Dave.
Fine business. And next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. It was quite a busy week, actually. I received my Trimble Res 720 L1, L5 GPS timing receiver from the distributor. I actually purchased 2. I purchased one for me, and I purchased one for the developer of GPSD. and he recently received his in the mail. So the agreement was if you give him an engineering sample, he will add support to it, and also if you give him all the documentation. So I got him all of the documentation. So GPSD should support the Res 720 once he actually gets it. Once he starts doing some more testing and debugging, there's a new, an updated version of the binary protocol, Trimble's protocol that had to be added. It didn't just work with the version of the protocol with the previous generation. So that's underway, and the plan is with my Res 720, I'm going to use that for a multi-channel, meaning 4-channel VLF receiving system. This is mainly going to be for the B field receiver, both orthogonal loops. Also, John Gibbons emailed me a file spec for the for the great data. I'm still not really clear about exactly what FLDigi does. If it records temporary wave files or if it just generates CSV data. I believe it generates CSV data according to the file spec that John Gibbons gave me, but I'm not really sure if there's anything else that's done, or if it's just, you know, the frequency and the amplitude being logged and recorded and then decimated into the file spec. So I'll have to try to figure that out. Paul Nicholson, the author of VLFRX Tools, is working on an updated version of EBSynth. EBSynth is a program used to generate, it's used as an all-in-one program to send amateur messages over ULF or VLF, depending on what kind of rig that you wire up. What you needed to actually send messages of a couple characters is you needed a 10 megahertz reference from a standard or a GPSDO, and that would generate the carrier, and it would lock the phases to the reference, because EBNOT uses binary phase shift keying as a modulation. So he's working on a new version that can use the pulse per second signal from a GPS receiver, and this way that'll overcome a problem where if there's a problem with the phase, it would be able to recover. With the 10 megahertz signal, it can't be recovered, and if it's midway through broadcasting a message, then that message is lost and it can't be decoded. So he's actually working on an updated version, and that was actually inspired by me asking if the audio injector sound card for the Raspberry Pi could be used for this purpose. So I'm glad that I actually got him doing this. I sent all of the technical information about the ADC 6140 evaluation board to Scotty, both mechanical and the electrical information, so he could add support to his adapter board um, including the connector part number, orientation, everything else like that. I forgot to include a picture of the rear side of the evaluation board, just so you can just to give her a better idea of where the connector is and how it's oriented. Let me know if there's anything that you need, if there needs to be more information. And Bill, I wanted to thank you for all of your hard work with all those parts that you have printed out. Thank you for this. They look great. I admit the documentation isn't really the easiest to read, but it's but we'll definitely work through it. This will be good because building this will allow the original designer of this to improve the design quite a bit. So thank you again, and we will get together later. And that's all I have. Back to the net.
Well, fine business. Next, I'm going to give Jules a second to think about what he might say. We'll go to Michael, AAAK. Go ahead, Michael.
Well, greetings to everyone listening. Back to you, Dave.
Well, that was a short. But next on the list, we have Jules, K2, KGJ. Go ahead, Jules.
Thanks, Dave. Greetings to everybody. Interesting week with several relatively light snowfalls, but nonetheless required a fair amount of work clearing the driveway and so on to make sure we didn't get a freeze up. Anyway, managed to get the hardware completed for a test of my above ground controlled temperature chamber. And I'm going to be running that this week to see how things go. I have the heater is controlled by an I2C switch, so I can either do pulse width modulation or a simple bang bang servo. And we'll see how that works out. The goal will be to regulation to within ½ degree C, down to an external temperature of 0 C, or not 0, I'm sorry, 0 Fahrenheit, or maybe a couple of degrees below that. Looks like I can do that with no more than 2 watts of heater power. So we'll hopefully have some information next week for the net, and back to net.
Well, fine business. And
I'd love to see a photo of that once at some point, and he has it.
Sure, yeah, I can do that. I've got some photos of the heater block, the unit itself, the chamber, how it was built, and so on. So I'll send you some of that, Dave. Sure.
Sure.
okay, next on the list is Scotty, WA2 DFI. And Scotty, I did get an email from Tom this week, so he is surfacing. His big question was, when is Scotty going to send me some boards?
Okay, I guess that's a fair question. I did get Jonathan's update info, so I'm reviewing that. Did you send me the size of the board, Jonathan? Because I don't recall getting that.
No, I don't have a caliper here, so I can't give you exact dimensions.
Oh, just an inch close, ruler's close enough. I just need to know, is it 2 by 2 or 3 by 3 or 4 by 4? It looks square, so.
Yeah, it is rectangular, but I sent you the Gerber files.
Oh, that's right. Okay. Yeah, I did see those. So I'll look those up and get the info. I don't have a Gerber reader on this machine yet, so it kind of stopped me.
Oh, okay. Yeah, I was wondering if you would be able to get the size from the Gerber files.
Yeah, I should be able to.
Actually,
anyways, so
I could probably get you the size. I uploaded the Gerbers to OSH Park, and that gives the size. So I'll just get that. I will get that information to you.
okay, that'd be good, because I think I did check and I do have enough IOs to do that, because there's a lot of unused ones on the connector, on the HSMC connector. So, and they're programmable. So I think we'll be able to do that just fine. And then while the CAD guy is beating on another project that's my day job, I've been working on the clock module carrier board, something we're going to use to build to test the clock module when we build it. And we've been through the BOM on the clock module and the RF module, so we're getting just pretty close to pulling the trigger on those as soon as I'm comfortable with the carrier board that it fits. I think we're going to go ahead and build those, and because I really want to have some hardware in my hands for HAMSci, so even if I don't have all of it, I can have at least something to show. And see what else. I guess that's it. The clock module carrier will help us debug the clock module. So when we build that, we have funds to lay that out. So we're just ready to go as soon as I make sure that I can get all the parts. Not many parts for that board, but I did have to make some changes on the carrier board because there's a few parts that are not available anymore. But it's just regulators and things like that that are not going to be. They're just a nuisance factor. You know, they have if they have a slightly different footprint or require some different electrical connections, then you have to make those changes. But and of course buy the right part. But it's not like the FPGAs where you're stuck without one. There's always another one that you can use. So anyway, back to Dave.
Well, I think I've covered all 17 of you, and so we should be open for general discussion.
I guess I'd like to start by just encouraging or asking, are there people on here who would be interested in presenting at HAMSci who have not submitted an abstract yet? And I do notice that we don't really have any abstracts in from the Personal Space Weather Station project. And it'd be really nice to get some updates on things.
Yeah, I will.
I can get you something on the NASA thing, on the machine learning thing. I mean, just basically a summary of the paper.
That would be perfect.
I'll do that tomorrow.
And I can do the same thing for a hardware update with our course change with the hardware changes. Something that people will want to know.
That would be really good.
Yeah.
Yeah.
So that's up on the HAMSci page, right? The place to submit the abstracts.
Yes, it is. I can bring it up right now. So you just go. Yep. You just go to the hamsci.org. You click on the banner that says HAMSci Workshop 2022, the weather connection. And there's a big blue button here that says submit abstract to HAMSci Workshop.
Hey, can't miss that.
Yeah, that's right.
So by the way, the talk for Hamcation is how to build an SDR with no parts. So I don't know how that's going to go.
That should be an awfully popular talk, with given all the supply chain issues.
And I'm really afraid that people are going to take it the wrong way as a how-to presentation to build one. If you can't get any parts. that won't turn out well.
Well, aren't there those people that like? I'm not a gamer, but like, aren't those gamers that like go into Minecraft and they're able to like build whole computers and things out of the parts inside of?
So this is another layer of abstraction. We'll build a software-defined radio in software.
Yeah.
And we won't need any hardware at all.
Yeah.
Well, we're in the gaseous phase,
That's right.
otherwise known as vaporware.
Vaporware.
Jules, do you have anything you'd want to present on the update with the magnetometer, or Dave Witten?
Well, no, I mean, we've done some experimentation. I mean, I was working a bit with Noel Pettit regarding the FluxGate FLC 100, but I don't really have anything in, I mean, I have some basic information about what kind of stability you need on the power supply, the desired analog digital converter bit rate, or not bit rate, but bit width, and so on and so forth, but nothing really in presentable form at this point.
Yeah, and you don't think it'll be there by March?
Given my other workloads, no.
Okay. Yeah, I think Noel had it submitted an abstract actually.
Yeah, he did. What he was going to submit something on building a station using the FLC 100. What I suggested to him was that what he really needs to do is present the basic parameters of the ARM 3100, the FLC 100, why you choose there's the temperature stability requirements, all of the requirements you'd need to meet in order to use it. But then again, you know, you look at the FLC 100 series and you're going to be spending around $500 or more to implement that, as opposed to maybe $100 to implement the ARM 3100. So you will have to have a good reason to do it. And then when you're going to spend that kind of money, you want to be able to get the highest performance you can. So I'm kind of pushing him towards the information that he's developed so far regarding performance of the unit and the parameters you have to use to actually get data on it that's better than the ARM 3100.
Yeah. Yeah, it looks like he's planning on doing a talk about the whole smart network in general. He mentions here the ARM 3100 and the FLC 100. I don't know, I have to read this more carefully, but I'm not sure if it's more of a high level overview of the smart network. I think that's what it is, more than like a detailed comparison of the different sensors.
Yeah, that's my understanding at this point, although he did say the last time I communicated with him that he was thinking of providing information on how to build a station with him. But again, there's a world of difference between the ARM 3100 and the FLC 100 flux states in terms of how you do it and what you have to do to get top performance out of them.
Yeah. Okay.
So that's as far as I know. It's a work in progress with Noel right now.
Okay, that sounds good. Dave McGaw, do you want? I saw Jim LaBelle submitted an abstract.
Yeah, that's good.
Yeah, Dave, are you going to submit an abstract at all?
I'm not sure what I would talk about at this point. You know,
can you talk about any of your?
I'm sorry, you broke up. What was that?
Did we lose him?
Yeah, you're freezing, Nathaniel.
Yeah, he's frozen. Yeah.
I'm freezing.
Yeah.
Yeah,
you need to close the window.
Yeah, I do. That took me. If I keep having trouble, I can call in on my phone instead.
Okay, you're okay right now. So
okay. Yeah, I said, what about would you be interested in talking about any of your polar other research projects, talking about, you know, the antenna systems or the things that might be of interest to amateurs?
I hadn't really thought about it. Yeah, so what's Jim going to talk about? Do you know?
I could let you know.
Is it's going to be further on the AM Doppler?
Yeah. I just saw that he submitted. I didn't actually. Read his. I haven't really read these yet. But no. Okay. Yeah, his title is AM broadcast signals observed at South Pole.
Oh, okay. That's new.
Yeah, so actually he did tell me about it when I went to AGU.
Right. Yeah, well, I've been talking to him about looking for various things in our polar data, including WWV, but I guess he's looking at the AM.
Yeah. So I mean, if he's doing, so he's clearly doing a science result, but if you wanted to, you know, give a presentation about some of the antenna, some of the engineering things you do to make that would probably be well received.
That's actually a good point. We haven't done a talk on the Trimpy antennas.
Yeah.
Which we could do.
Yeah. So that would be really nice.
Yeah, of course, another AM related thing is our Viper stuff, the sounding rocket that we flew.
Oh yeah.
But I don't know where that's going to get at this point? You probably know more than I because you were at AGU.
Yeah, no, but I don't think I do know more than you
Yeah,
do.
and we haven't had a
That was when you were still you were trying to figure out like what stations you were hearing.
yeah, exactly.
Right.
Yeah, there's so many that are coming in.
Yeah.
Basically every channel is occupied. So how do you know what station you're
Yeah.
actually receiving? So the idea there is start with the clear channels.
Yeah. Jonathan, do you know what you haven't submitted an abstract yet, have you?
So just curious, how long are these talks? 20 minutes?
Probably about 20 minutes.
Okay.
Yeah, I try to keep them to be 20 minutes.
Yeah, I could probably do one on the loop antennas and the preamp
That'd be
systems
great.
that we use. Sure.
Do you think you'd be able to come in person?
I don't know yet.
Okay.
Part of it's funding.
Yeah. Well, that might be able to be helped out.
Oh, okay.
So in the past we've been able to. I can't make any promises until I see everything, but
right.
We've been able in the past we've been able to pretty much fund all of the people who are actually giving presentations.
Oh, okay, very good. No, it'd be
So, who need the funding.
right.
So, yeah.
Yeah, so I could yeah, that would be appropriate.
Yeah. Yeah, that would be really good. Jonathan, do you have did you submit an abstract yet?
No, but I wanted to just go over that with you now that I have more information. So what I
Yes.
was going to do was I was going to talk about using the evaluation board with Scotty's adapter board, and I was going to talk about the signal flow and what's going to happen in the FPGA, and what needs to be done.
Mm-hmm.
And I was going to make that like a short presentation because, well, there's not really that much to actually talk about. So I wanted to make that short.
Mm-hmm.
And then I was thinking about doing another presentation that's longer, that'll describe the VLF system that we installed at your house, the signals that I received, and uh, different sorts of detections and plots and everything else. And also cover the Tonga event.
Mm-hmm.
And I also wanted to do something on a little something on the amateur signals that I received from the system. And I mean, not really going into major detail, but kind of giving like a science case for it, since this is more science themed.
Yeah.
Technical themed.
Mm-hmm.
So I was gonna cover SAQ, amateur signals, the features of the system, different things you could do, and Tonga, and that would all be in another presentation that'll be longer than the one about the VLF module.
Okay.
If there's enough space for it, but I'll have to check my work schedule.
Mm-hmm.
I believe that I will be traveling to. I will probably be traveling to Texas sometime in March. I don't know when.
Yeah. Tell them they can't send you the week of St. Patrick's Day. Are you there?
Sounds like you lost him.
Are you there, Jonathan? Yeah, it does sound like we lost him.
Yeah, no background noise. His
No.
microphone's open.
Well, hopefully we'll get some abstracts from him.
He may need to adjust his AE35 unit antenna.
Yes.
There he is.
Are you there, Jonathan? Well, I guess maybe we'll come back to him. Jim, how are your, so you started talking about the Tonga data you were collecting.
Yes, if I could, I will put some of that up for a moment.
Mm-hmm.
Let's see, where the heck is it? There it is. Okay, this is one of the infamous Ohio plots, node 7. I've got these in order by node number at the moment. The green lines are just every 5 hours to make it a little bit easier to read. The red vertical line is the time of the Tonga event. And I've been trying to correlate that with other stuff going on here, and I've been having some trouble with it. One test I was doing is how long from the Tonga event until I first start seeing some kind of perturbations in the ionosphere at the various stations.
Yeah.
So you can see a 2-hour delay here, irrespective of what might be causing that right now. There's another Ohio station, 2 hours. Pennsylvania station, 3.2 hours.
Mm-hmm.
Now, if there's that much difference between a station 7,600 miles from the volcano and one 7,300 miles, it implies something awfully slow propagating, and I shouldn't have seen it this soon. But nonetheless, let's go on. Here's another Ohio. That's about 2 hours. Another Ohio. And that one I didn't do because I wasn't sure which of these events to correlate it to. There's Arizona. It was 7/10 of an hour to the first thing that happened. So it was less. But again, it doesn't make sense with distance from the volcano. It doesn't make sense that that would be the volcano. Here's Georgia. And I wasn't sure what to pick on which of these perturbations to pick, but I picked the first one again. It was only 1 hour. That doesn't make a whole lot of sense. That Georgia's a little bit closer to the volcano than Ohio is. But again, if you assume that it could have made that much difference in the propagation time, then I shouldn't have seen anything anywhere near this soon after the event. And here's something from the Netherlands. It was very interesting, but again, I don't know what to make of that, if anything. So that's not looking too good. I've tried looking at some of the period of some of the ups and downs and correlating that, but that's not working too well either. Now, so there may well be some other event that I should be looking at and am not, or it may be that I should look at one of these further out events. But at the moment, I am not having a lot of luck correlating with anything that would have corresponded to the Tonga volcano.
Yeah.
So any other ways of investigating it, I would be grateful for information.
Yeah. So I mean, one thought is if we have some sort of an if we had some sort of an estimate as to how fast the disturbance would be propagating, or when we would expect to see it, then we might know where to look.
Yeah, I was kind of assuming maybe, or in my head anyway, some sort of a acoustical thing. But the research I've been able to do on that says that the acoustical wave on something like that should propagate at different speeds depending on how far it is away.
Right.
With the speed slowing down.
Now they gave some of those numbers in that paper I shared a week or so ago, right?
Yeah, I think that's where I got that information.
Yeah.
But I haven't quite been able to get my head around how to make that happen.
Which part do you mean? What part do you mean how to make that happen?
How to make something happen with the propagation speed as it's decreasing, and the times, again, if I'm even looking at an event that is related to the Tonga volcano.
Yeah.
And I'm thinking that maybe I should estimate some sort of propagation time and then look that far out from the volcano and see if I can see anything.
Yeah.
When I tried to estimate the propagation time from the information in that article, I wasn't successful, but I need to go back and look at it again.
Well, what are you using for speed of sound?
Well, according to this article, the speed of sound doesn't have too much to do with it. That it can actually propagate faster than the speed of sound, depending on the height above the ground, the atmospheric pressure where you're talking about propagating, and depending on the distance from the event.
And they also said depending on the type of event too, right?
Right. Yes.
Because like in the article they talked about, if you had a volcano, it was kind of one particular case, and if it was a nuclear explosion, it was a different case.
Yeah.
Well, just to point out, speed of sound's roughly 700 miles an hour.
Right.
So if it were at that rate, you would be getting a wave 10 hours later.
Yeah, and I'm wondering, this paper talked about the propagation of that edge being faster than that too.
Yeah, I've seen that it was like twice the speed at altitude.
Yeah, it was. Well, it turns out there's one curve that shows it varying both ways. It can be twice the speed. It can be about the same speed, depending.
Yeah. So that would be something between 5 and 10 hours. So.
Yeah. So maybe I should be looking further out. Maybe some of these things further out are a response to the volcano, and these things close in are some unrelated event.
I wonder if it might be better looking at some of the more professional instruments first, like looking at SuperDarn, because it might be easier to see a signature, an unusual signature there than
That's
it
a
is
good
here.
point.
Yeah.
Yeah, that's good.
Yeah,
So, like,
well, you might also look at the air pressure records, because that definitely picked it up.
yeah. But that'd be interesting too, to confirm that the air pressure record, whatever's going on in the air pressure, is propagating at the same speed as what's going on in the ionosphere. They're not necessarily going to be the same.
No, they're not, but it gives you at least a point
starting
where you
point.
know that something came through.
Yeah. Can you give me a reference for checking the air pressure records? If you can send it to me later, that's fine.
Yeah,
Well,
I don't know, but who was?
So what I don't know either. So on the on some of the listservs, so both on the Hamsci listserv and on I think there's a Dopplergram listserv, which is, if anyone, there's this, if you aren't on the Dopplergram listserv, it's a really good listserv to be on. A lot of people put observations that they had from their houses, and a number of people posted pressure measurements from their homes. And I basically went through the email list chain and I compiled it all into a PowerPoint, just copy and pasted everything I saw into a PowerPoint. And I can send you a copy of that PowerPoint. Maybe that'll be helpful.
That would be good. Where do I find that Dopplergram list?
Let's see. Probably if you Google Dopplergram. I can get it. I'll put the link in the chat so everyone can get it. So Dopplergrams are actually doing something very similar to what the grape is doing, but they've been around a lot longer than the grape and then Hamsci. And it was actually started by Peter Martinez, who's the same person who designed PSK31. So I'm getting the link now.
I took a look at the super darn plot on this, and because of the time of the day in which this occurred, there wasn't a whole lot of propagation that super darn picked up. It just is pretty much nothing to see there.
And that was the Blackstone one.
Yeah,
Yeah.
I guess it must be HF. I don't know what frequencies they use, but
They typically run about 12 megahertz during the day and maybe 10 megahertz at night.
okay, yeah, this was at night in North America, and so there's not enough propagation there for super dawn to show anything.
Yeah. Or else it's showing like ionospheric scatter.
Yeah.
That might not be. I just put the Dopplergram in the chat.
Yeah, I'm looking back at the discussion on the Hamsci list, and there's a thread called "Pressure Wave from a Volcano" that mentions people seeing pressure waves on WEEWX, people running WeWix, wee weather. Greg Troxel reported he was logging station pressure every minute and saw a positive negative excursion pair. There's also high frequency METAR data that was suggested.
Yeah, that's where I got a lot of the things I was sticking in my PowerPoint presentation.
Right. I think there was some, I'll have to go back and look, but I think there was some discussion on the time nuts list as well, because I know at least one person in Europe reported that's on that list reported seeing a wave come through.
Certainly Attila Canali
Yes,
mentioned it.
That's who I'm thinking of.
Yeah. He said he was monitoring the atmospheric pressure, I think, at a lot of stations worldwide.
Yes.
I had something I wanted to say to Bill Kelsey when we get to a pause. Yeah.
Go ahead, Dave.
Okay, Bill, I don't know. I think that stuff you were showing that you were 3D printing, was that related to the to that hammerhead seismometer?
Yep.
Okay. And I don't know, I have never really done it myself, but when you're 3D printing and trying to print things that require supporting material, isn't that often done with a different plastic that can either dissolve away or can at least is different than what you're targeting and can be removed easily so it doesn't stick
Well,
to
I got the support material out of this piece here. I just had to take a knife in and pry it, and eventually it snapped out. There's still a couple rough spots in there, but that difference between using a $150 printer like I am and using a $6,000 3D printer like they've got at school that they printed off a case for me back 6, 8, 10 months ago, and there they use multiple nozzles and different materials to make structure, and like you say, they wash it away when they're done. And mine, I can't feed two nozzles. I've got one nozzle, so it has to be the same material.
Okay, I got you. I just, I wanted to be sure there wasn't some misapprehension there.
No.
Bill, which brand of unit do you have? Do you have the Creality or which unit?
The 3D Pro or 3 Pro.
Okay. Yeah, I have the Creality, and it does a good job, but you only got a single nozzle to work with, as you said.
Here's the data from Greg Troxel on the Hamsci list. So he says he's located in Boston and that he thinks he's seeing two pressure waves. He said the first one has a positive negative peak at 15:15, 17:29 Zulu on January 15th. So that's here and here. And he says, given a 4:15 Zulu eruption, he'd estimate he's about 15,000 kilometers away. And he's wildly assuming a 300 meter per second propagation. That's 13.9 hours, which puts at 1809 Zulu, which is, he said, fits well. And then he has a second one over here at 4:48 and 5:15 Zulu on January 16th. He says he does not understand the timing of the second wave. Without thinking much about it, he expected to be 1.5 times around the world. So he puts that there. And Jonathan, you showed us this plot, right?
Yes, that's the one.
Yeah. And so you really believe that is from the same volcano event?
Yeah. Yep.
So that propagated over here very quickly, right? Because the volcano erupted around here, and we see that
very fast.
So why would this one be so fast and the pressure wave be so slow?
Well, because so with these VLF transmitters, it all depends on the path. The path between the transmitter and the antenna. And depending on where the pressure wave hit along the path, it could cause a disturbance. So what I did was I asked some other people for some input, and nobody really had anything that was really concrete that you could definitely say that that little dip was caused by the pressure wave. But see that dip in amplitude, that's caused by the effect of the path. Probably specifically where the radio wave refracts along that path. Like, let's say that the shock wave reached a certain part of the ionosphere, and it was at a certain part of the path. That'll cause a perturbation.
Yeah.
And that happens with SIDS too, quite a bit. But whether you see a SID or not depends on the path. And there was a paper on that, and I one of the people from my VLF groups, he posted it, but for the life of me, I cannot find it. So I'm going to try to get that paper and just to use that as a reference. But it's really hard to say without much data. Now, there is one thing.
I wonder why it would be for so long too. It's better part of an hour.
Well, so the other option, and I'm not sure how to use this software yet, but there's modeling software called LWPC. And what it can do is it can generate, it runs a model that will output this plot at my location or at this location. Paul uses it quite a bit for amateur transmissions. He also used it for SAQ, but I'm not sure exactly how to use it for this purpose. And that could now that dip could just be normal variation. But it looks a little different than the previous 2 days. That's why that I'm kind of going with this might be because of the pressure wave.
Yeah.
I mean, I don't. David, what do you think? What's your take on this?
Well, I'm thinking, the timing is strange. Onset is about an hour after the event, and then it looks like it lasts for about an hour. Trying to think if there's any kind of ringing in the magnetosphere that might explain something like that, but the hour delay is puzzling. I mean, there could be some very quick effects, especially given the large amount of lightning that was involved. There could have been some electron precipitation induced by it, but I would have thought that actually would come on much quicker.
Well, I was also thinking about the lightning too, because I was thinking that perhaps maybe the sudden increase in atmospheric noise might have caused that dip in amplitude at the location. I was thinking that could have been it too. I mean,
now remember, there was also some geomagnetic activity at the same time, so you'd have to separate that out.
Yeah, and that's also that might be
what you might. Here's one idea: is if you're recording broadband data, see if you see any whistlers induced by the lightning.
Well, I would have to be in the Whistler footprint, and according to the geomagnetic models, the Whistler footprint is like out in the Bering Sea.
Right.
So, and it that that would have been that would have been an amazing Whistler storm that would have been great to capture.
Right.
But unfortunately,
There's there are the three ways that electrons travel. One is, the cyclotron action. Then there's pole to pole, and then there's a drift. The drift might give you something of that order, but again, the 1 hour's a little odd.
Yeah, it is.
Now here's a GPS TEC movie from Catherine Mitchell.
Mhm.
And
oh boy, there is something traveling there.
yeah. Now we're at 14 UT, but it might. So actually, trying to line things up to this might be better.
Yeah.
A better way to try and do things.
So that came over the Northeast about 1600 hours.
Yeah.
Yeah, that's right. I'd seen this. This was quite striking.
I can play this again. There's a lot of stuff
And then
that
there's
just
more coming. Yeah.
keeps going. And now like there's that over there.
Mm-hmm.
Is there any other analysis of that? Do this one more time.
oh, and one thing I forgot to mention, there was a VLF receiver in Scotland that captured a very similar plot to mine. So when you're thinking about the path, Culture Main to Scotland versus Culture Main to Springbrook. It also depends on how fast.
I think
this,
maybe was it right there? Hold on. Like right around 12:30 UT, we start seeing waves going from west to east over here.
Yeah. Now there's the strong one in the Gulf at
In the Gulf.
1344. And it takes a while to get to the Northeast.
So now you see the waves going.
Mhm.
Yeah. So,
Yeah, so like
Jim,
1500 hours.
This is probably the way to try to line up what's going on in the grape data. If you can see waves that line up in the grape data with waves that line up with this movie, you're probably onto something.
Okay, that would be interesting. Where do I get that?
I'll email you this this presentation.
Okay, thank you.
Yeah.
Yeah, could you email that to me too, Nathaniel? I want to see how that lines up with our AM Doppler data.
Yeah. Let me let's see. Let me make sure I have. Yeah. Stop sharing. So yeah, I can get that to you.
Thanks.
Because I think just looking, there's so many wiggles going on in that grape data, trying to say which one is associated with which is really tough. And I think this is where, like, you know, with the GPS TEC, it's got the real strength in that you basically put it on a map like this, you get an image and you can see the patterns. Like looking at any one particular dot doesn't really tell you much, but looking at them all together, you can really get some sense of what might be happening.
Mhm.
And I think what we have to do with the grape data is we need to figure out how to do a similar sort of thing where we can take all of those undulations and somehow make some sort of an image where you can see a wave propagating from one area to another coherently. And I know I have one student who's working on something like that using an approach that they came up with at Dartmouth. Or they were using a Dartmouth, but you know, anyone else who wants to take their hand at a whole bunch of grape data and try to figure out how to visualize it so that you can get coherent wave structures out of it.
Yeah, that would be good.
Over a geospatial area, that would be very powerful.
Yeah.
And also, yeah.
I'm thinking that in doing any calculations related to the propagation of anything, that I should be probably using the mean distance between the receive station and WWV instead of the location of the received station, because we are dealing with stuff that goes on in between the two stations, not at the received station.
Yeah, that's a good, I think that's a good approach.
I think I'm going to go back and pull that data too. I can get it.
Yeah. I think that's a good approach. And I don't know, I know this is still really early work, so I don't know if you want to present it at the Hamside workshop, but if you did, and like it started coming together a bit, you know, I can still, I have flexibility with the abstract deadline since I know the organizer.
Let me cogitate on it for a while. It's awfully early though.
Yeah.
Yeah.
But it is a possibility.
Yeah.
And the other thing to remember is Hamside workshop is a workshop. It's not a conference. So like if you wanted to put it together and just say, okay, this is like an early investigation, you know, we really just got started with it, but we're starting to try to piece together some things. That's an okay thing to do too.
Okay, let me cogitate on it a little bit.
Yeah.
I'm not going to be able to attend in person, but I'm hoping to be able to attend virtually.
Virtually, yeah. That sounds good.
All right.
Interesting.
That's about where I've gotten to on this thing.
Well, I think that looks really good, Jim. Well, anything else, Scotty?
You're muted, Scotty.
You're still muted.
Okay, I lost my control panel here. Nope. I'm good. Sounds like you got your hands full.
I think so.
But you know the organizer, so you'll make out okay.
Well, somehow we're gonna pull through, right, Bill?
Hey, Bill, one thing, you're gonna be at Hamcation, right? You want to bring some more tangerines? Some live
In
ones.
what now?
You want to bring some more tangerines like you did last time we had
Oh,
live?
yeah, I can do that, yeah.
I've got, I'm gonna bring 1,000 stickers, so we'll have plenty of stickers to hand out. And Dan's working on the demo, which looks like it's gonna be pretty awesome with his couch antenna.
You should go get lots of bags of like Lay's or boxes of Pringles or something like that at the booth, so you don't have a chip shortage.
Oh, that's almost,
We could do that, I suppose.
that's almost funny enough to go do it.
I know. Well, if you're handing out all these tangerines, you know, you should also.
Pepper has no
Don't
chip
give up
shortage.
your day job.
Yeah. Well, we'll have to tell them this is the closest you're gonna get to a tangerine for a while.
That's right. We have no chip shortage here. Come to Tapper booth. We'll fix your chip shortage.
That's right.
Oh man, that's just bad enough to be okay. Because what are you gonna do otherwise? You gotta laugh about it. Otherwise you're
miserable.
stay home.
Just make sure it's chocolate chip.
Oh, I like that.
Yeah.
Yeah, I would
we
definitely.
could-
I would support chocolate chips.
We could have all different kinds of chips. So we could have chocolate chips, we could have Pringles, we could
But
have
no computer chips. You can't have any
So-
chip but
so
electronic chips.
I can't bring a bag of like 7400s that I have.
No. You're out of those. You can't have
Okay.
those.
No, it's got to be organic.
So what we'll do is I'm going to make up a chart. It's going to say PCA 9615 out of stock, delivery 2 years. FPGA out of stock, delivery 2 years. Pringles in stock. Chips Ahoy
right.
in stock. Yeah, so
I'm staring at my kitchen here. I have a periodic table of the desserts where every element, it shows the element, and then it shows like a H has Hamantaschen, and CS has creme brulee or something like that.
so what
And
does
for-
cesium have to do with creme brulee?
I don't know, but it's on the periodic table of the desserts.
Jeez.
It's just like the periodic table of elements, really.
Yeah, okay. That sounds good though. So thanks, Nathaniel. You just gave me my humorous slide to start off my presentation.
You're welcome. Glad I could do something.
Nathaniel, I'll see you in the morning.
All right, that sounds good. And so,
That'd be
I
great.
did hear from Virginia Tech. They said they're going to get back to us about the data after tomorrow because their engineer Kevin's on paternity leave, but they're talking with him tomorrow about it. So,
All right.
Oh, and by the way, Bill, we got you a badge, so it should be at the check-in there, at the vendor check-in. So if you want to show up on Thursday, you can, or I don't know when you're coming in, but you get into to help set up if you want.
Yeah, I'll be there late in the evening after hours on Thursday because I have some commitments, and I was going to come in a previous day, but certain medical things have gotten in the way of that. So anyway, we'll see you.
Okay, but you'll be able to
probably
get
on
in early.
Friday.
You'll be able to get in early Friday.
Right.
And I don't know what if you go to the website, they'll tell you what the setup times are on Friday. There's like 6 to 9 a.m. or something like that. So you can get in early anytime during that time if you want.
All right. That's
So
great. Thank you. 73.
7-3.
See you guys. Got to leave.
73.
Later.
Bye now.
Bye, everyone.
Good night, everybody. I put the periodic table desserts in the chat window.
I'll check that out. Thank you.